Yes, sir. Good evening, sir.
Good evening. Okay, let others join in.
Okay, sir.
So you're confident?
Yes, sir. Somewhat, sir.
Okay, did you could look at the snaps?
Yes, sir.
Did it make sense? Somewhat.
I didn't open the JNT file, sir. I have to open it.
What?
Sir, you sent on file in group, no, sir. I have to open it, sir. I didn't open that one.
No, they're basically the snaps. If you can't open
Okay, sir.
that file, I'll open now.
Yes, sir.
The GNT file.
Okay, sir.
Software there. This is that file. Basically, I put all the images there.
Okay, sir.
You can see the screen, right?
Yes, sir.
So what do you think the circuit is?
Ohm's law, sir.
galvanometer ammeter மாத்திருக்காரு.
Video Prakash.
Sir, what is this, sir?
Yeah, hold on. See, this is the voltage source, right? I'll just explain. This thing is a voltage source. Don't remember? You've been to lab, no?
Yes, sir.
This thing is
Yes,
the
sir.
voltage source. Sarika.
Yes, sir.
Okay. So from there, I'm connecting. This is the positive terminal. From there, the current will come out. Right? The positive terminal is the
Yes, sir.
red one. The black is the negative terminal. Current will enter. So current will leave this positive terminal, and I'm making it pass through the resistor because to be safe. I burned one voltage supply, no, few days back. Remember?
I don't know, sir. I was absent, sir.
Okay. See, it got burned because I didn't put a see, as soon as I have this supply, it's safe to have a rheostat or a resistance in series with this supply, because some amount of resistance will reduce the amount of current coming out of this voltage source. Okay. So
Okay,
have
sir.
this positive terminal of this voltage source entering this one end of this rheostat. This is the bottom, I think. Okay. Other end is at the top. Okay. So the current will enter
Okay,
here,
sir.
go through this rheostat and come out of this top rod, and then right now the current is passing to minimum resistance because it just passed only this part of the resistance. Okay. If I move this thing,
Yes, sir.
then it'll pass up to from here to here, and then go up and go through this rod and come out. So if in the middle, and
Okay,
the is 30 ohms, if you keep it here, then the current will pass in 15 ohms. So safe thing to do is to have this rheostat in series with this voltage source and keep this point in the middle. Okay. So that way I can reduce the amount of
Yes,
current.
sir.
And this current coming out of this rheostat is entering this resistance, which I have to verify the Ohm's law and find the resistance. And the current coming out of this this thing is a voltmeter. Okay, this is an ammeter. Okay, so whatever current is passing through this resistance should pass through this ammeter.
Okay, sir.
Okay, maybe in the lab it will be properly visible. And this voltmeter here, that is connected in parallel with this. Sorry, this is the ammeter, right? See, this is ammeter. Okay, so the current that is coming out of this resistance is entering this ammeter. Okay, and the current
Okay, sir.
going out of this ammeter, this is that wire which is entering this voltage source. So this is one complete series circuit. I'll just redraw it. Current from the positive terminal is coming here and will come via like this. Okay, and then out of this this another rheostat, sorry, this resistance is coming out like this and entering this positive terminal is ammeter. Okay, and the negative terminal of the ammeter current is coming out, and this wire which enter this voltage supply. So this one series circuit. How many are present?
So that voltmeter is connected
Sir,
parallel to that
practicals day,
resistance,
all
sir?
the connections will be done also.
I'm not sure. Actually, this I would like to keep the components. I've opened the connections. Okay, so that you should know how to connect.
Okay,
Okay,
sir.
so this is a voltmeter which is connected in parallel to this resistance.
That's right. Okay, sir.
Yeah, I'll just show it. This one, this positive terminal, this voltmeter is connected to the positive end of this resistance, and the negative terminal is connected to the other end of the resistance. Okay, the parallel is not visible properly. So this is the parallel connection across this resistance. So this is a voltmeter which measures the voltage. The blue one is the voltmeter which is connected in parallel to this resistance I'm measuring.
Okay, sir.
Let me check how many are there. 9. Karthikeyan, Ritu are here. Okay. So anyone has some doubt? This red or purple one is this. You can see the series circuit, and the voltmeter is connected to measure the voltage across this resistance, which I'm trying to measure. Okay, so if I look at this. So this is a circuit diagram. This is the voltage source, right? Battery. Okay, this key I have not put. Okay, and this is the rheostat, which is that you should put to save this thing from to be safe. Otherwise, it will burn, right? This is the rheostat,
Yes, sir. Yes, sir.
and after that, this connection. This is the one which I'm trying to measure or verify ohms law for this resistance. That is this resistance here.
Okay, sir. We have to draw that diagram, sir.
Of course, aim
Okay,
apparatus
sir.
required, circuit diagram, formula used. Okay, after that, only this is correct. You will be allowed to do the experiment. Okay.
Okay, sir.
So ammeter is there in the series, which whatever current is flowing through this resistance will flow through this ammeter. So basically, this ammeter will measure the current in this resistance, and this voltmeter is connected parallel to this resistance. So whatever drop is across the resistance will be the voltmeter reading. Okay, this is the voltmeter which is connected in parallel to this resistance we are trying to measure or verify ohms law for. Okay, so the circuit is clear.
Yes, sir. Clear.
Yes, sir.
So now the table will look like basically V is the independent variable. Actually, V I can change by adjusting the voltage here. Okay, it goes in steps of 2, 0, 2, 4, 6 like that. But you should be careful not to increase too high, else you will burn this thing. So what you can do is you can make this thing 2 here, and then here the resistance right now is minimum. Okay, because the current here right now will go here. Just a minute. The current coming out like this will go here, and then from here we go to this one. So the resistance included is minimum here. Okay, so if you have to change the voltage, you can make this thing 4 volts. Okay, before making it 4 volts, increase the resistance to somewhere here. So if this thing is moved here, means the current will flow up to this value of resistance. Okay, and it will come out like this and go through this rod. So if this much of resistance is now included in this circuit. Okay, so basically I have to get V and I across this resistance. Okay, so that V I'll get from this voltmeter reading. This voltmeter reading give me V, and this ammeter reading give me current I. Okay, so it does not matter whether I mean this voltmeter is different from this reading of this voltage source, because here there is a resistance. No, so if it is 4 here, means here will be 3.5. Okay, because there will be some drop across this resistance. It will be 0.5 volts. So remaining 3.5 will drop across this unknown resistance. Okay, so this way I can move this resistance to get different values of V and corresponding values of current. Okay, when you actually did in the lab, we didn't have this rheostat. We just changed this knob to different values, 4, 6, 8 like that. So I didn't even have the voltmeter. Okay, I just put whatever is the reading here that I put as voltage here. But now we can do it better. Okay, because we have the voltmeter here. So this voltmeter reading is V, and I can measure current. And then I have to plot V on the x-axis, which is the independent variable, and I on the y-axis. And the curve will pass through zero because when voltage is not, the current will be zero. It will look like this. So if you take the slope of this curve, it will give me 1 by R. From this, I can find the resistance. Okay. This is not a good way of drawing. V should be on the x-axis. I should be on the y-axis. Okay. Then the reciprocal give me the reciprocal slope will be the resistance. Okay. So aim is clear. Determine actually to resistivity is once you find the resistance, you can find the resistivity. Because we have that formula, right? Once the resistance is known, R equal to rho into L.
Rho L by A, sir.
Yeah. Okay. So the length of this coil wire, it's written in the one sticker is here. Okay. There the length is mentioned. So that length you can use, and the diameter is mentioned. So from the diameter, I can get the area as pi by 4 d square. Okay. Both the length and the diameter are mentioned here. In case if it is not there, means you just have to open this wire. It will be long, and you have to measure it using that scale. And diameter you have to measure using the screw gauge which is here. Hopefully, I can manage without that because it's written in this one. But if they ask us a Viva question, you should be able to answer. How do you get the length of this wire? You just have to open this coil. It is a loose coil. You can open it. Okay. And hopefully there is a long scale in the lab, which you use for optic experiments, right? It will be around 1 meter or something. So using that, we can get the length of this wire. And the diameter of this measure can be measured using the screw gauge. So area is known, length is known, and resistance you get from this graph. Okay. So from this, I can find the resistivity, which is the material property. So the aim is to determine resistance of wires by plotting potential versus current. Actually, by plotting this graph of potential versus current, we get the resistance. After using that formula, and from length and area, I can get the resistivity value. Apparatus required, obviously, there has to be a source of voltage. Okay, an ammeter for measuring the current, voltmeter. Okay, and rheostat is always required. And connecting wires, obviously. And resistance wires, yeah, that is that coil. This is the resistance wire, for which I'm verifying the Ohm's law and finding the resistance. So it's not difficult to actually once you get this experiment, you should have this picture in mind. So once you have this picture, obviously you can write the apparatus required. One is the voltage source, rheostat, the resistance, which is for which we are going to verify Ohm's law, is unknown resistance, voltmeter, ammeter, and of course you can have a key. Okay, so if you have the circuit diagram, then you can write the apparatus required. The heart of the experiment is the circuit diagram or the schematic diagram of optical instruments, optical experiments, and the tabular column, because you should know what you have to measure and what you have to calculate. Okay, here both are you are just observing V and I, and drawing the graph and calculating the slope and finding the resistance as a reciprocal. And once I find the resistance, I can find the resistivity rho from knowing the length and area. Okay, length and area are actually given in this particular thing. But in case it's not given, we just have to open this coil. It's a loose coil. You can open it and measure the length. And you can find the diameter of this wire using a screw gauge. Okay, from that I can get the area. Area is pi by 4 d square. Area is pi r square in terms of radius, and radius is d by 2. So if you use that, you'll get area as pi by 4 d square. This is of a circle of diameter d. Okay, and least count of ammeter. So basically, whatever is the suppose this is the ammeter, right? Suppose it can measure a maximum of say 5 amps, and there are 50 divisions. So the least count is 5 amps by 50. Least count is nothing but one division. What is one division value? Okay, so if there are the maximum range of this ammeter is 3 amps. Okay, and the number of divisions is 30. So each division will correspond to 1 by 10 amps. It will be amps per division. It's 0.1 amps per division. So this is a least count. So you can measure ampere to the accuracy of 0.1 amperes. So current is jumping from 0.2 to 0.2, can say with 100% accuracy is 0.2, but it's between 0.1 and 0.2, the maximum value will be 0.1. Or I can say measure a current of 2 amps, and the next higher value I can measure is 2.1 amps. So in between values I cannot measure. So the maximum value will be 0.1 amps. So that is the least count. Okay, so least count of any instrument will have a least count. Like your watch will have a least count. That will have a least count of seconds, because you can tell the time to an accuracy of 1 second. Right now the time is 9 p.m. 20 minutes and some 30 seconds. Next I can say is 31 seconds. I cannot say 30.5 seconds. Okay, so here the accuracy of the clock is 1 second. It's the minimum that you can measure. That corresponds to 1 division. Okay, length of the wire you can measure, or it's given in the thing. So this is the table. So this is the most important thing. First important thing is the diagram. Okay. Second important thing is the table. Aim you can write from the question itself. Once you have this diagram, you can write the apparatus required. Okay, after that you should know the formula. And then procedure that you can write later. Main thing is the table, and then you have to go for the experiment. Okay, so VI, and then you can find the resistance. These things you forget it. So any and you have to have a graph sheet, or I'll give it. Yeah, from the graph the slope is okay. And once I know the slope, I know the resistance. Once I know the resistance, I can find the resistivity. Okay, so this is the first experiment. Any doubts? Karthikeyan?
Sir,
Ah,
the least count is 1 division by what is the
so what is the, see, ammeter will measure current, no?
yes, sir.
Okay, so what is that 1 division correspond? It corresponds to 0.1 amps. If the total maximum rating of this ammeter is 3 amps, and there are 30 divisions from
Okay, sir.
one end to another end, then 1 division corresponds to 3 amps by 30, right?
30, what is it, sir?
30 divisions.
30 divisions.
Yeah. See, you have a common ruler, no? Scale.
Yes, sir.
So 0
yes,
mm is
sir.
there, 1 mm, sorry, 1 centimeter is there. Okay.
Yes, sir.
Okay. And between 0 and 1 centimeter, how many divisions are there? 10 divisions are there.
10 divisions, sir. Yes, sir.
Okay. So 1 division corresponds to 1 centimeter by 10 divisions.
So it's 1 by 10, sir.
Yeah, that's 0.1 centimeter.
Okay, okay, sir.
And 0.1 centimeter is 1 mm.
Okay, sir.
So 1 division of that scale corresponds to 1 mm. So you can measure a distance of say 4 mm. Next you can measure accurately as 5 mm. Okay, if it is in
Yes,
between
sir.
4.6 mm, you cannot say with 100% accuracy, right? It's 4.6. Okay, so maximum error is
Okay.
1
Yes,
mm or 1 division.
yes, sir.
Okay, so least count is the minimum that you can measure that corresponds to the 1 division of the instrument. Similarly, set for a watch, it can give up to a 1 second accuracy, right? See here, this one it says going 36, 37, 38, right? I cannot say 37.5. So the least count of this clock
Yes,
is
sir.
1 second.
Yes,
Okay.
sir.
Similarly, voltmeter, what is the range of the voltmeter divided by the number of divisions? So if it is 5 volts and say 50 divisions, it will be 5 by 50. That corresponds to 1 division. So what does 1 division correspond to? How many volts? That is the least count.
Sir, that total division we have to count 1 by 1, sir, in the
It's not difficult.
voltmeter.
No, it won't be difficult to count. You see, you know, it's not difficult to count, because for each each 5 division there will be a big line. No,
Okay, sir. Okay, sir. Yeah, okay. It'll be easy. Yes, sir.
it's not difficult. You can check in the lab.
Okay, sir.
See, if I meter like this, say this is 0 amps and this is 5 amps. Okay, then we mark 1, 2, 3, 4, 5 like that. 1, 2, 3, 4. And here it will be like 1 is the middle, and then 1, 2, 3, 4. 1, 2, 3. So you can figure out here there are 10 divisions. So 10, 10, 10, 50, right? 2, 3, 4, 5, 50. 50 divisions divided by 5 amps by 50 divisions.
5 amps by 50. Okay, sir.
The basic idea is what does one division correspond to? That is the least count.
Yes, sir.
So you can also get the least count from here itself. From here it's 1 amp, but how many divisions are there? 10 divisions. So 1
10
amp,
divisions.
10 divisions.
1 amp by 10 divisions. Yes,
So
sir.
it's 0.1 ampere per division. This is the least count. Okay. So any doubts? Start again. His mic is off. Nitish,
Sir, yes, sir.
it's clear, no?
Yes, sir. Clear, sir. Sir.
Theory part should be clear. Otherwise, experiment anything can happen. But theory part it should be clear. Okay.
Okay, sir.
Okay, shall I go to the next experiment? This manual is there with you, or I can just post it again. It's there with you already. Okay. So basically, aim. Once you get the experiment, you should have that aim. Obviously, is there in the question. Same as the question. Okay, maybe you have to write in a different way. Once you get the experiment, you should have this figure in your mind, or you should draw the figure. And after the table. Okay, so once I have this figure, I can figure out what is the apparatus required. Whatever is there in this circuit should be the apparatus required, right? After that, once you have the table, you know what should be measured and what should be calculated. Here, both are observed, and this is a calculation. After, I have to draw the graph and get the slope. From the slope also, I can get R. Okay, and then I can find the resistivity. Can I move to the next one? So
Yes,
what
sir.
is this thing? Yeah. So this is what? This is the meter bridge, right? This one is the meter bridge. This is that wire from here to here. What is the length of this wire?
100 centimeters.
100 centimeters, which is 1 meter. That's why it's called meter bridge. Okay, so meter bridge will have this sort of a metallic strips. Okay, so what is the resistance of the metallic strip? 0. It's a perfect conductor. And there is a gap here, and there's a metallic strip from here to here. Okay, and then there's the second gap here, and there's a metallic strip here, here like this. Okay, that's what is shown in the diagram also. The diagram, right? This is the metallic strip, and this is the middle metallic strip, and this is another L1. So there are two gaps, one in the left, one in the right. Okay, so here again I have a voltage source. As soon as I have voltage source, I should have a rheostat to control the current, otherwise this will burn. Okay, and I put this rheostat knob in the middle to be safe, because I know at least half the resistance is there in the circuit to protect this voltage source. Okay, so the current which is coming with the positive terminal will enter one end of this rheostat, and from the top it will come out. Yeah, top it will come out. Yeah, basically this voltage should be applied to this 1 meter wire. So top it will come out, and this wire is long wire, which is connecting to the other end of this 1 meter wire. See, the current is coming out of this positive terminal. It's entering this rheostat, I think at the bottom. Okay, and from the top, the current is coming out. Okay, and it is entering through this long wire because it's in the other end, so that's why I put a long wire. Okay, here. Okay, so the full voltage is dropped across this 1 meter wire. See, this is the voltage source, no? The potential across this, whatever is the voltage here, that's dropped across this wire. So one end of this voltage source is connected to this one end of this wire, the meter, 1 meter long wire, and the other end is connected to the negative terminal. Here they have not put resistance, but it's safe to put the rheostat here in case to be safe. Okay, so this rheostat is put here, you can make it 0 if it is required. Okay, so to be safe, I put a rheostat here. That is rheostat here. Okay, is it clear? This part. Okay, and in the gap,
Yes, sir.
in the left gap, you put a this standard resistance. So one end of the resistance you put is here, and the other end is connected to the negative terminal. So in one gap, you put the standard resistance. Okay, in the other gap, you put the unknown resistance, which you have to find out. This again that coil. Okay, so this is the resistance box of known resistance. Okay, and this is the one which you have to find out. And after that, from the middle of this strip, I have a galvanometer and connected to the jockey point here. So this is the middle point of this middle strip. This is the middle strip, right? This is the middle point. Okay, from that I take a wire, connect with the galvanometer. So this is the middle point. This is where is my galvanometer? This should be the galvanometer. Okay, so from here the wire is going to the galvanometer. Okay, and the negative end of the galvanometer is going to the jockey. This wire is like this. Okay, this is the jockey, and this jockey I have to place it in the wire somewhere here, and then slide it. This wire is long because I have to slide from here to here, right? If it's required. Is it clear? The jockey is here. There's a second. This jockey is not required. This is the same as that one only.
So
it is-
that galvanometers contain the middle part,
Yeah.
sir. The okay, sir.
See, this is the middle knob, right? Okay. So wire from the
Okay, yes,
this
sir.
point is coming. The positive terminal is the galvanometer, and the negative terminal is coming out. Okay, and there's a long wire here, and then it's going to the jockey. Okay, and this black thing I'll touch this wire to make the connection. This one is basically
Yes, sir.
okay. I made this wire long because I have to move from here to here, right? If it is required. The best thing is to have the balance point in the middle itself, only because the accuracy you know. That can be obtained if I have this resistance value close to each other. So Wheatstone bridge, this is the Wheatstone bridge. There are 4 resistances. One is this one, known resistance. The other one is set this one, and the third one is this length from here to here, and this is the 4th resistance. Okay, so this is the bridge. Okay, so currently this bridge will be 0 if the potential of these 2 points are same at point B and this point D. That will be true if the ratio of the resistance R to X, R by X should be equal to resistance of this L. L is from A to D. And obviously this will be 100 minus 100 is in centimeter. So L should be in centimeter. Okay, so R by X should be equal to L divided by 100 minus 7 because resistance of this part is proportional to L. So the proportionality constant get cancelled. So resistance of this part is L into something, some constant. This also of this part is 100 minus into some constant, which is the same constant. So R by X equal to L by 100 minus L. So from that I can find the unknown resistance. Okay, I'll just show it here only. Yeah, this is the Wheatstone bridge principle, right? When the bridge is balanced, this is true only if the bridge is balanced. So the meeting will get cut in 10 minutes. After that, you have to reconnect. So R by X should be L by 100 minus L. Okay, L can be measured from this scale. This scale. Once I know this point, so from here I can measure. So there will be 2 scales. One is starting from 0, another one is starting from 100. So don't make the mistake. You have to choose the one which is starting from 0 from the left. Okay, suppose the jockey point is here. So this is my L from here to here. So I have to choose the scale which is having 0 here at this point on the left side. Okay, this is my 100 minus L. So this is L from here to here, and this 100 minus L. So L you can measure. This currently should be 0. Okay, until that thing I have to keep moving this. So obviously you can understand it when R is close to X. Okay, this L will be close to 100 minus L. So balance point in the middle. When R is close to X, this is approximately 1, right? So when this is approximately 1, L will be 50. So the balance point in the middle. The balance point should be in the middle because accuracy is high in the middle. Okay, so to get the balance point in the middle, this is a resistance which I'm free to choose. What do you think should be known? This resistance is known because there are two knobs here. One is in terms of 10, another one is terms of 1. So this 10 knob, if I have one division, the resistance is 10, and then if you have two divisions here, then the total resistance is 12 ohms. Okay, and this resistance is of some fixed value. Suppose this is 15, then I have to make it 10 and then 15 here, and I can get different readings by adjusting this rheostat, or I can change this voltage here. That way I can get different readings, and still the balance point in the middle, because this resistance value I'm keeping it close to this value of the resistance here. Okay. Another way to repeat the resistance, repeat the experiment is to change this resistance, known resistance values slightly, but not to. Suppose this is 15. One reading I can make it 15, another one 16, another one 17. Okay, this side I'll make it 14, 13, 12. I should not get too far away from 15. Only the balance point in the middle. Are you getting this point? Suppose this resistance values which I'm measuring, it's say around 20 ohms. You don't have to know that. Actually, make this thing 20 and see whether the balance point is in the middle. Okay. Suppose the balance point is here for the current when the current is 0. So should I increase this standard resistance or reduce the standard resistance to make this balance point come to the middle? Understanding the question?
Yeah, to decrease the resistance, sir.
Yeah, because
To come in the middle.
it's equal to L by 100 minus L. So the balance point is here. L is more, right? Okay. So that means to decrease this L, I have to decrease R. So I have to reduce this resistance value to make this balance point come here towards the middle. And if the balance point is here, means then this resistance value is less compared to this one. So then I can increase the resistance value a little bit to move the balance point here. So with that, I can get an idea of what is the approximate. I'll catch this balance point in the middle. After that, I can change from that. I can change this value a little bit towards the or increase or decrease a little bit. So the balance point shift a little bit towards right or a little bit towards left. So the accuracy is not. It will be good because if the balance point is toward close to the middle, then the accuracy will be high of this instrument. Okay, let me look at the table. Yeah, this you can choose, right? Known resistance by choosing the knob, and there you can measure. And obviously, this you can calculate. You do not measure. Okay, and then you can find X. The important thing is choose this value of R such that this balance point is close to 50. Okay, once I get one reading, from there I can change R a little bit higher and lower. So the L will go a little bit away from the middle point. Okay, so you can repeat these different values by changing the resistance value a little bit. Once I get the approximate value corresponding to the middle point. Is this clear? I'll just repeat. This is a different. Oh yeah, as far as experiment is concerned, this is the only one. So this is unknown distance is fixed. So you can have this, you can move this jockey point to get the null deflection. Suppose the jockey point is moved here. So the deflection is null. That means the resistance value is less here. So I'll increase this little bit. Now the balance point will move here. So you keep increasing the resistance value R until the balance point is approximately in the middle. Okay. So that will be the first reading. After that, to get the second reading, from this value of resistance, increase it by just 1 ohm. And the next will be next 1 ohm. Okay. And after that, you can decrease the resistance value by 1 ohm and 1 ohm, and maybe another 1 ohm. So that way the balance will be close to the middle. Okay, so aim is to find the resistance of the given wire, standard wire, which is unknown. Okay, using the meter bridge. So once you get this x1, you should have this figure in mind, or you should draw this figure in the paper. Okay, looking at this figure, you should know the apparatus required. Obviously, voltage source, and then there will be a rheostat here. Okay, and then known resistance, which is that red box, this one, and then unknown resistance, which is this coil here. Okay, and now galvanometer. What did you need? That's it. So apparatus meter bridge, obviously meter bridge is required. This is the meter bridge, right? This full thing, the one with the strip and this wire. This wooden thing, this is the meter bridge. Okay. So meter bridge, obviously voltage source, galvanometer, resistance will be the standard resistance, jockey. I think this is part of the meter bridge, but you can write it, jockey, and resistance wire of this unknown resistance. This resistance box is known resistance. This is unknown resistance. Okay. Screw gauge for finding the diameter of the wire, because after finding the resistance, if you have to find the resistivity, you need the area of the wire. For that, you have to get the diameter. For that, you need the screw gauge, and obviously connecting wires. Okay, so name apparatus required, and formalize this one R by X. From this, I can find the unknown resistance, because this is the known resistance. R is known resistance, and L is measured. Okay, from this I can find X. Procedure, we read it. You have this document with you. Okay, this is the table. So the heart of the experiment is this circuit diagram. Okay, and the table. Whatever you calculate should be in the end. Okay, whatever you observe should be in the beginning. Okay, this also calculated. No, should be after the measured ones or observed ones. So once I know X, I can find resistivity if required. Again, that same formula, R equal to rho into L by A. L is known, E is known, sorry, diameter is known. From there I can find area, and then I can find the resistivity. Any questions? Kavya,
No questions, sir. No
Ah.
questions.
theory part should be clear. It's not difficult. Okay.
No, sir.
Yeah.
Yeah.
Fine. So we do the next one. So next is exactly same. Like first you have one unknown resistance, say x1, and then you remove that, put the second one x2. Same way you have to find x1 and x2. And then the third thing, you have to put x1 and x2 in series. There you can find x1 plus x2. So, and then you have to check whether x1 plus x2 is the one which you have measured as x1 plus x2. This is the one where you have both of them. But first you have to just have this R1. You have to remove this one. Just have this one resistance. So for this first resistance, find R1. Okay, by taking 3 readings. And then remove that R1. And then